Hello and welcome for the fourth part of the tutorial on how to design a football clit using the 3D Shape Designer license and its three apps XDesign, XShape Design and xGenerative Design. In the last video I finalized the soil, adding configurable clits and some aesthetic features like ridges and colors. My shoe is operational now, but it doesn't look finished at all. The upper part is completely grey, thus I must bring colors to it. That's what I'm going to do here, but first, I display my cutting surfaces. I integrate my subdivision surfaces, namely upper part, and the two cutting surfaces in my design sequence via the input function. As I decided in the last video, I store every input in a group. I also give them appropriate names. As I want a line browsing the shoe, I duplicate and displace my second cutting surface in the vertical direction. And you see that line appearing between my two surfaces. With these cutting surfaces, I want to split the upper part into four. This part, this one, the line, and the lower one here. To get every single part, I have to split it step by step. The function split only gives one side of the division depending on the value of the input ori, which is a boolean. To get both parts, I turn this input into a dynamic one, and I apply a true and a false. Then I obtain two items. The first one constitutes my first part. As I will use them again, I name and place my booleans in a group. To get the next part, I have to split the second item, so I extract it with the function getItem and I fill it with the index 2. Then, the process is the same, so I duplicate the split function and I keep the links. I only replace the inputs object and the splitter. Here again, I obtain two parts. I repeat the steps one last time to get all my splits. Finally, I get my items and I gather them in a column. In order to organize my design sequence, I decide to create a relay box for each part. As its name indicates, the function only relays the information. When I click on them all, they appear in blue. Okay, the preliminary work is done. I can now work on each part one by one, starting with the top. every part will get different features, and I'm going to adorn the first one with strips. In the first place, I apply the function boundary on the part 1 and the output gathers the edges of the surface. However, I would like to have the top limit and the bottom limit separately. Thus, I disassemble it in order to get every single items. The output is then a long list that I have to split into two sublists. In the function sublist, I indicate the indexes of the first and last item to get my sublist. The 16 first elements are forming the top boundary. The remaining elements are forming the bottom boundary, that is to say from 17 to 52. I assemble the elements of both lists to get my two closed curves. With the function divideCurve with a dynamic connector for the curve input, I divide both curves in the same way. I want this natural number to represent the number of strips, so I have to multiply it by 2, because they will get together by pairs to form the strips as the diagram is showing. Let's set the value 50. Then, each point at the top will be linked by a line to a point at the bottom. I transpose the output to have one column per pair and apply the function spline. To generate the strips, each line has to form it with the neighbor line. The function shift creates an offset in a list. Thus, I apply a shift of 1 unity on my splines. Then, the function blend creates a surface from two curves. By applying the splines from the shifted and the original lists, I get my surfaces. As I want to alternate the colors of these strips, I use the function odd-even, so as you know, it gives me two lists. And I color the even list in a dark blue and the other one in a lighter blue. I hide everything to see the result. And I finally choose the color red for the odd elements. That's it for this part. Let's work on the part 2 now. I would like to add a texture feature like small spherical holes. To do that, I use the function triangulate. I set an element size of 20 mm and I apply this function on my surface. It's the same process for a surface meshing before your simulation. I generate planes from the triangles with the function planeCurve. And I place a dot at the middle of each plane with the function pointOnPlane. Okay, I have my dots. However, they are not necessarily placed on my surface, I have to project them on it. To do that, I create lines normal to the planes and starting from the dots. Thus, I'm sure they cross the surface. And, as you probably guessed, I intersect the dots with the part 2. Now I'm sure these dots are located on the surface. Then I use them as centers for the spheres with a radius of 1.5 millimeters. After the assembly of the spheres, I use the function trim, which creates a trim geometry from 2 geometries. This generated geometry depends on the values of the inputs ORI1 and ORI2. I decide to color the obtained surface in white. I hide everything, and here is the final result. We have 2 parts left. The next part is the line. It will be very fast because I just want to color it. And it's done. Let's tackle the last part. My aim is to make appear strips again. To do that, I want to cut the surface with parallel planes, so I have to create these aligned planes before. I decide to create them along a straight line that I generate with the function lineNormal, and I set it normal to the ZX plane and crossing by the point O. Then I set values for the start and the end so that the line is a little bit longer than the shoe in both sides. By dividing it, I generate points. I use these dots as centers for the normal planes. As you can see, they are vertical, but I want to rotate them with an angle of 45 degrees. That's why I need an axis of rotation that I create by intersecting my new planes with the XY plane, and I obtain infinite straight lines that I better hide. Now, with the function plane angle, I can create new planes with a rotation angle of 45 degrees around the axis. I noticed that the first plane could be further to the left, so I just modify the line start value and I save my work. Now, let's address the concept of loops. As in your programming languages, you can create a loop in xGenerative design. I want to use it to cut my surface and recover every pieces one by one. Here, a loop is bound by a loop start box and a loop end box. To set the number of iterations, I evaluate the number of elements in my planes list, and I set the result as the maximum value in my loop. Then I have to indicate the input values. The first one is my surface. that is to say the part 4. As a second input value, I apply an empty list with the function listEditor. At the end of the loop, I want this list to gather every pieces of the surface. I add the function split. What I want is to cut my surface and recover both sides. The left side is added to the list of pieces and the right side is cut again by the next plane. That's why I pick the splitter from the list of planes with the getItem function, and the index is the iteration. When I connect this output to the input val1 in my loop endbox, the value connected becomes the input value for the next iteration. As in the loop actually. You've probably noticed the loop symbol on my boxes. It means they are completely part of the loop. Now let's work on the val2. I do exactly the same, but I change the boolean value to get the left side of the split. To finish the job, I just add the values in a list with the function appendList. This list gets a new value after each loop. And you see it loading. I want it further to the left again, and it directly recalculates the result. Let's put my loop in a group. In my list of pieces, there are some errors because, as you can see, the last planes are not crossing the surface at all. I remove these errors from the list with the function removeError. Here again, I want to alternate the colors so the odd-even functions is my friend. I want to add a color that evolves from the first even element until the last one. Thus, I will use a gradation. Previously, I have to prepare something. I generate a sequence of 35 numbers from 0 to 1. You just need to understand that each number is associated with one piece. If I connect this sequence to a black and white gradation, 0 corresponds to black, 1 corresponds to white, and the numbers between correspond to an intermediary color. Then I have to honor France with its colors. You can add as much colors as you want on a gradation. On mine there will be 3: blue, white and red. And we are done with that French shoe. A lot of modifications have been done in this video. Now there are strips everywhere, holes on top, a gradation, and a super shoe for your next game. Useful notions such as the loops have been addressed, so you are now almost ready to use xGenerative design. I say almost because I invite you in a very last video on how to define the parameters you want to control from the right environment, but I will also teach you a best practice if you want to visualize and configure your xGenerative elements in other apps. So don't miss it, guys. Bye! You are interested in the 3D experience? TPS supports you with webinars, specialized trainings, customized coaching, but also services and integration offerings of the platform. Follow us on the social media or on our website tps-fr.com, and don't hesitate to visit our channel.